If you are ever being confused by SQL joins, especially how joins actually work, and the difference between different types of joins, you are not alone. In the next 15 minutes, we'll explain everything related to joins and break it all down with clear examples. In this video, you'll learn how to join data from related tables and dive deep into different types of joins and the comparison between where and join clauses. Let's get started with how to join data from related tables first. From time to time, you may get a task that requires you to query data from related tables. For example, think about the online store named the Sci-Fi Collective. There are two tables in its database. One represents the products that are being sold, while the other represents the reviews of products. Since each review is for a specific product, the review table needs the help from product ID to remember which review is for which product. As a result, the two tables share a common column, the product ID. The product table is the parent table, while the review table is the child table in this relationship. If you need to see what the two tables look like with some data, here you go. If you ever want to understand how products are reviewed, you will need to pull data from both tables, at least the name column from the product table and the review text column from the review table. Of course, as you do that, you need to map each review to its corresponding product. The query that answers your question looks like this. Select name, review text, from product, join review, and product.productID equals review.productID. This query takes advantage of the join on clause to join data from two tables. As you may have guessed, the join on clause here in this query maps each review to its corresponding product and makes sure that the result contains only the properly mapped products and their reviews, as you can see here in the result sample. Although this query looks straightforward, we do need to explain a few things, answer a few questions, so that you can have a thorough understanding of how join actually works. First, what's the general syntax for retrieving data from related tables? Second, what does the join on clause do? And third, what's the dot notation and how do we use it as in product.productID and review.productID? So the general syntax first. The general syntax of joining data from related tables is presented here on the screen. We have some assumptions here, which is that the two tables, table 1 and table 2, are actually related. The two tables are listed here. From table 1, join table 2. The condition of the join is listed here on table 1 dot column equals to table 2 dot column. This is a shared column between the two tables. In the select clause, it will list the target columns that you want to show up in the result. So that's the general syntax. Next, what does the join on clause do exactly? The answer to this question has two parts. First, the join clause computes the Cartesian product of the two tables. Second, the on clause filters the result based on the given condition. What's the Cartesian product? The Cartesian product between two tables is the set of all possible combinations of rows from the two tables. Think about the product and the review tables. To produce their Cartesian product, you will grab every row from the product table, and then combine it with every row in the review table. For example, if the product and the review tables each have only 3 rows, we will start from the first row in the product table and combine it with every row in the review table. And the combined rows all go into the results. The same can be said for the second row in the product table. It will be combined with every row in the review table, and they all go into the result. The third row in the product table is no exception. It will be combined with every row in the review table, and they all go into the result. So in the end, the join clause by itself produces a Cartesian product of 9 rows. Even if many of the combinations don't make much sense, we don't care here. All we care is to produce a result of all possible combinations of rows from the two tables. That's why the example Cartesian product has 9 rows. That's 3 multiplied by 3. Remember, the product table has 3 rows, and the review table has 3 rows. When you multiply 3 by 3, you get 9. Okay, that's the first part of the answer. So what does the on clause do next? The on clause applies the filtering condition to the Cartesian product and only picks the rows in which product.productId is equal to review.productId. In short, the on clause picks the rows where mapping between a review and a product makes sense. In the end, the select clause only picks the 2 target columns, names and review text, and returns them as a result. So on the screen, only the cells within the red highlighted rows and columns would be included in the result. Now you know what the join on clause does. Let's move to the next question. So what's a dot, and how do we use the dot notation as you see in the product.productId and review.productId? Well, the dot notation is a SQL syntax that's used to separate parts of a name. Product.productId, for example, refers to the product ID column in the product table. For another example, product.name can refer to the name column in the product table. Dot notation is especially handy when you query related tables because it helps you to be specific about the columns in case they have same name, such as product.productId and review.productId. This approach makes it clear which column and which table you are actually referring to so that it can prevent confusions. Beyond that, if 2 tables that you want to join have multiple columns that share a name, you may want to rename them in the select clause to prevent confusions. For example, you have 2 related tables, employee and department here on the screen, and you want to join them to get the names of the departments to which employees belong. However, both tables have a column named name, so you need to use the dot notation to specify which name column to select. So the query that gets the job done properly will look like this. Select employee.name, department.name. From employee, join department on employee.departmentId equal to department.id. The ID in the department table is the primary key, and its corresponding foreign key in the employee table is named department ID. It's worth mentioning that the result may show 2 column names that look exactly the same, like this. To prevent this confusion, you can rename the columns with an alias via the as clause, like this. All it takes is to add an as clause that follows the actual column names, so that you can specify how the column names should show up in the result. Okay, that's everything about how to join data from related tables. Let's move to discuss the different types of joins. So this is the general syntax of how to use the join on clause to join data from 2 related tables. There are actually more than one type of joins, and the join keyword can be replaced by the following options, including inner join, left join, right join, and a full outer join. Different types of joins will give you different results. The inner join is the same as join and returns only the rows that have matching values in both tables. In contrast, left join returns all the rows from table 1 and the matching rows from table 2. If a row in table 1 has no match in table 2, the result row will include the table 1 record with null values for table 2 columns. For example, the left join between the product and the review table will lead to a result looking like this. Every match between the product and the review tables will be included. Beyond that, the products that have never been reviewed will also be included. For example, the atomic nose hair trimmer was never reviewed. It will still be included in the result, but its review text value will be null because it doesn't have a match from the review table and there is nothing to fill up that cell. Right join returns all the rows from the table 2 and the matching rows from table 1. If a row in table 2 has no match in table 1, the result row will include the table 2 record with null values for table 1 columns. Full outer join returns all the rows from both tables, including the non-matching rows. If a row in table 1 has a matching row in table 2, the corresponding result row will simply include the data from both tables. If a row in table 1 has no match in table 2, the result row will include the table 1 record with null values for table 2 column. Similarly, if a record in table 2 has no match in table 1, the result row will simply be the table 2 record with null values for table 1 column. The relationships among the left table, the right table, and the returned results are summarized here on the screen. It's worth noting that the left join, right join, and full outer join may lead to query results with null values. One side effect of getting null values in the result is that you need to handle them very carefully. Null values can cause errors if you try to perform calculations or comparisons. Okay, that's everything about the different types of joins. Let's move to talk about the comparison between where and the join clause. As curious as you are, you may be tempted to try to join in two tables using the where clause. Can you do that? Yes, you can. You can certainly use the where clause to join two tables as long as they are related. The two examples that use join clause and the where clause to join tables are listed side by side on the screen. To use the where clause to join data from related tables, you need to list the two tables one after the other in the from clause and separate them using commas. And the where condition is used to do the filtering. Both of the two queries work and achieve what you want. However, whenever you need to query related tables, the join clause is generally preferred. There is a strong evidence that people make less mistakes using explicit join than the where clause, so it's less prone to errors and more straightforward to modify or debug. Beyond that, the join clause is typically much more optimized by database system engines than the where clause. So using join clause does give your database a better performance than using a bunch of where clause to join tables. In case if you wanted to run the queries that were covered in this video and replicate what you saw, you can find everything you need from this GitHub repository. The URL of this repository can be found in the description of this video. The easiest way to replicate what you saw from this video is to load data into a tool named SQL Online. You can follow the README files in each of the corresponding folders, for example, Chapter 1, to see the detailed instruction. Of course, you can follow the instruction to install your preferred database system locally and then load the scripts, but we are going to simply use a tool that makes things easier for us to start. The tool is named SQL Online. Essentially, that's a SQLite database system running on the cloud. Once you follow the instruction in the README file to load the corresponding script from what we prepared for you, you will be able to run all the queries that were covered in this video and see the same results. In this video, you took a deep dive into the join clause, learned about how join actually works, the different types of joins, and the comparison between the where and the join clause. If you find this video helpful, give it a thumb up, subscribe, and drop your questions in the comments. I would love to hear what's working for you and what needs to change. If you want to go deeper into database design, this video is based on the book Grokking Relational Database Design, which walks through these ideas step by step with real-world examples. You'll find the link to the book in the first comment.